Hi everyone, let's solve Leetcode 162, find peak element. Problem is, a peak element is an element that is strictly greater than its neighbors. Given a zero indexed integer array, numbers, find a peak element and return its index. If the array contains multiple peaks, return the index to any of the peaks. You may imagine that numbers -1 equal to numbers n equal to infinity. In other words, an element is always considered to be strictly greater than a neighbor that is outside the array. You must write an algorithm that runs in O big O of log n time. Okay, let's look at example 1. In this example 1, 2, 3, 1, we're looking for a peak. So here 1 is less than 2, so not a peak. 2 is less than 3, not a peak. 3 is greater than 1, also greater than 2, so 3 is a peak. We return the index 2. Here we're given this array we're looking for a peak. So 1 is not a peak, 2 is a peak. 2 is greater than 1, greater than 1. We could do output 1 because so your function can return either index number 1 where the peak element is 2 and index number 5 where the peak element is 6. So at index 5, 6, we see that 6 is greater than 4. It's also greater than 5. Okay, so we say we must implement a solution that runs in big O of log n time. Otherwise, to solve this problem naively would be to scan and check, neighbors of each element and see which one is strictly greater than its neighbors. Now let's go ahead and implement binary search for this problem. Let's get the length of the array in n. Int n is equal to numbers.length. Okay, let's take care of some edge cases. First edge case is when the array has a single element if n is equal to 1. Now what we have to do is return 0 because that's the index. That's the only element in that. Let's add a comment here. It's a single element. Okay, another edge case is, say, the first element in the array is a peak. So how do we do that? We say if numbers in the first position is greater than numbers in the second position, and this will not give an index out of bounds error because we already have verified here that the length of the array is not 1, so it has to be 2. If it's 1, we just return. Okay, so here we're safe. So if this is the case, so we can immediately return 1 because that's the index of the first. Okay, so I think index of the first element is 0. Okay, let's also add a comment and say first element is a peak. Okay, now another edge case is when the element at the last position is a peak. So how do we do that? We do if numbers in n minus 1 is greater than numbers in n minus 2. Okay, so we return n minus 1, right? That's the index of the last position. So let's add a comment here and say last element is a peak. Okay, now let's do our binary search. For binary search, we need boundaries or pointers. So pointer 1 left, we've already taken care of the first element, so we can start at the next element after the first element. So we're not starting at 0, we start at 1. And then the other pointer right, we start at n minus 1 because we've also taken care of the last element. So now we do our binary search while left is less than right, and we don't do equal to because once the pointers meet, we don't want to continue this loop. Okay, so we get our midpoint. We'll do integer division here and to avoid integer overflow for big very large numbers, so right minus left divided by 2. Okay, so what we want to find out is that the element at this position, at this index, is strictly greater than its neighbors. Okay, so in order to do that, if that is the case, we'll return this index. If that's not the case, we'll keep searching other parts of the array. So to take care of that case where it's strictly greater than its neighbors, so we do if numbers in mid minus 1 is less than numbers in mid. So numbers in mid is greater than the element to its left, and numbers in mid is also greater to numbers in mid plus 1, the element to its right. So here we know we found a peak, so we can return mid. So that index had a peak. Okay, now let's move towards whichever neighbor that has a bigger value, because that could turn out to be a peak. So let's try the right one. So say if numbers in mid plus 1, because that's the right neighbor, right? If it's greater than numbers in mid, so let's go to the right because we could potentially find a peak element at the right. So to go to the right, we'll do left is equal to mid plus 1, right? And then the last case here is say the element at the left is greater than the numbers in the mid index. So we could just take care of that using an else condition, right? And rather than doing that, let's write it out. So if numbers in mid minus 1 is greater than numbers in mid. So here we found a greater neighbor. So we would go to the left part of the array by saying right is equal to mid minus 1. Okay, so when this loop finishes and we never met this condition, we never returned, jumped out of this while loop, then we would need to return the left, because that would be the position where the mean value in the array would be. Yeah, so at the left position it will be guaranteed that the peak index would be found there at that index. Okay, so this should be the solution. Let's go ahead and run it and see if it's correct. Okay, 2 test cases has passed. Now we will submit and make sure our solution is accepted for every other test case. Okay, great. Our solution was accepted. So that is it for this problem. I hope it helped. Thanks for watching, and please like and subscribe to my channel. And then I'll see you in the next video. Bye bye.